All right, so the recording has started. So let's see if we can do something about the assignment today. Because we finished lecture 1 to lecture 4, and the first assignment covers this part up to lecture 4. I think there is no question from lecture 1 because lecture 1 was just simple definitions, and uh, here this is actually lecture 2, constructing a frequency distribution using 6 classes. So if you have to pick the highest value, 23, 24 is the highest. If I go down, 27, so 27 is the highest value, right? So this one. So see, first of all, we take the interval, the width of the interval. So 27 is the highest one, and then we add 1 unit in it, right? And then we subtract the lowest one. The lowest one is 9, 7, 7, 6, 6, 4. So I think 4 is the lowest, right? Yes, 4 is the lowest. So this is 4, and divided by the number of classes, 6, right? So these number of classes in the denominator, this 6. Okay, so this will become, so the width of the class will become 28 minus 124 by 6, so it is 4. Okay, so let's say today is Tuesday, right? So anyway, problem 1. So first of all, the highest value was 27. Lowest value or the smallest value is 4. So therefore, width of each class is W is equal to highest plus 1 minus the lowest. It is not plus 1, it is plus 1 unit. So because my all numbers are whole numbers, so that's why my unit is 1. So that becomes 4. So this was number of classes here, right? 6 is the number of total class intervals or classes. Um, so it means I will start. So now I will write classes, right? So I will start from the lowest one, 4 plus 4, 8, 12, 16, 20, 24, and this will before 8 is 7. So 7 plus 4, 11 plus 4, 15, 19, 23, and 27. So 27 is the last one, so I can stop here. So you see 1, 2, 3, 4, 5, 6 classes. So with this class interval, automatically I will get uh, 6 classes. Okay, so let's see if I use the ruler. So now I need frequency. So either you can calculate frequency directly or you can use tally marks, right? So if you arrange them, it's very easy to count. But arrangement also takes time. So it's better if you make tallies or tally marks, whatever you call it. Okay. So after each table, let's say if I go down here, if I bring it down here, so maybe like that. Let me make it a little smaller, and I can make teleworks. Okay. So see the first one, 17. 17 is here. Then 12. If I go down, 12, 13, 7, 20, 14, 7, 10, 14, 7, 10, like that. Okay. So if you keep on going, you can write the frequency distribution. 10, 6, 18, 5. So 10, 6, 18, 5. 9, 9, 7, 14. 9, 9, 7, 14. 23, 13, 10. 23, 13, 10. 15, 13, 6. 15, 13, 6. 4, 10, 12, 7. 4, 10, 12, 7. 27, 9. 27, 9. 19, 10, 19. 19, 10, 19. 6, 18, 13. 6, 18, 13. 16, 7. 16, 7. 24, 7, 8. 24, 7, 8, 15. So I think it's finished here. So hopefully this is correct. You can check it. Okay. So if these are the tally marks. So now you can write the frequency. Okay, so frequency, if you write frequency, you can count 5, 5, 10, or 1, 11, 5 and 4, 9, 5, 5, 10, 6, 2, 2. So if you look at the so now if you look at the sum 20, 30, and 40, right? There were 40 values. So the total is 40. So that's it looks okay. Maybe you can just check it again if they are there may be a mistake. I did it quickly, so I don't know. Anyway, hopefully everything is good. So this is the answer to part A, right? Question number 1, part A. Make a frequency distribution using 6 classes. And then he said also construct cumulative frequency and relative frequency. So if I construct that, cumulative frequency will be the sum from top to bottom, and then relative frequency. So clear the mess. So cumulative frequency is CF. So 11, and then we add plus 9, 20, plus 10, 30, plus 6, 36, 38, and 40, right? So what we did, we added 11 here, plus 9, wrote it here. Then we added plus 10, wrote it here, right? Then we add this, wrote it here. Add plus 2, wrote it here. Add plus 2 and write it here. And then relative frequency, we divide all the frequencies by the total. So 11 by 40. So this is coming from frequency, not from CF. Okay. So 9 divided by 40. 10 divided by 40, 6 divided by 40, 2 divided by 40, 2 divided by 40. Okay, so this is how we got relative frequency. So this frequency, the relative sum of the relative frequency should be 1. Okay. Is there a question? Okay. So this is the answer to part 1. You can write here whatever, use calculator, you can write the numbers, approximate numbers. So if you want 11 by 11 divided by 40 is 0.275. 9 by 40 is 0.225, and this is 0.25. 6 by 40 is 0.15. 2 by 40 is 0.05. 2.40 is 0.05. So if you add them, it should be this is 0.5 plus 0.75, 0.9, 0.95, and 1. Okay, so exactly 1. The sum is exactly 1. Because they did not say anything about cumulative frequency. So when they don't say anything, we do less than, right? Less than cumulative, because it is not mentioned. If they ask you to find more than, then we will use more than. Otherwise, it is always less than. In the same lecture 2, we had histogram, frequency polygon, ogive, okay, and skewness, everything. Skewness comes after the mean. So this was lecture 3. B part is lecture 3. So if I do the C part first, right, histogram and everything, so then it is we draw the x-axis, classes on x-axis, right, and the frequency here, classes here. So I can start from 24, 4 to 7, right, 5 to 8 to 11. Then there are 6 classes, so I can make 12 dots. 1, 2, 3, 4, 5, 6. Let's say I can. You can make equal distances. That's not an issue. So let me do it again. So if I start from here, this one, so maybe how much now? 1, 2, 3, 4, 5, and 7. Okay, so these are your classes. So I took same distance for classes, but a little smaller gap in between. So this class is 4 to 7, 8 to 11, 12 to 15, 16 to 19, 20 to 23, and 24 to 27. Now the highest frequency is 11, right? So I can say maybe 2, 4, 6, 8. If I'm taking each dot as 2, then here will be 8. So if I'm taking this as 2, 4, 6, 8, 10, so that is it, right? So this will be your frequency. Now the first class has the frequency 11, the highest one. 11, 9, 10, 6, 2, 2. So the first one is 11. 11 is here. 11. So I can start from here, go up till 11, right? And then I'm using the pad, so that's why it's going here and there a little bit, but hopefully this is okay, right? So you can make it little neat because it's easy to work on the paper. The second is 9, so 9 is here, right? Between 8 and 10. Nine, and then 10. This is 10, right? Maybe it's little this one, right? And then 4, 6 to 2. So this is 6. This one is 6, and then 2, and then 2, right? So I can start from here, go to 6, 2, 2. This is 2, 2, 6. So of course here, because I'm trying my best on this tablet. So this is your frequency. If you want, you can write at the top. This is 11, this is 9, this is 10, this is 6, this is 6, 2, 2. Right? So this is your frequency histogram. So this is your frequency histogram. For polygon, you can use the same page if you want. What we do, we take the middle point and put a point on 11. Similarly, middle point of the second class, 9, right? 10. So we take the middle points here of each class, and at the top of that, we just put a point, right? And then we join the points by straight lines, okay? So if you join by straight lines, straight line, so again, because you can use a ruler to make this straight line, okay? So that is your blue one is your polygon, frequency polygon, frequency histogram, frequency polygon. So you can either make it separately or on histogram, you can make it, no issues. And then ogive. Ogive is cumulative frequency. So again, if you make two lines, again, make frequency 2, 4, no, now the total is 40. Now the frequency total cumulative frequency is the highest is 40. So maybe you can make 40 here and 5, 5, 5, 35, 30, 25. We can give 5, we can give 5, 5 uh, differences, right? So now you see here. I can extend it a little bit, 5, 10, 15, 20, 25, 30, 35, and so on. So here, again, you can make classes like before. So 4 to 7, and then 8 to 13, 12 to 16, and so on. 1, 2, 3, 4, 5, and 6, right? So again, you can write 4 to 7, 8 to 11, 12 to 15, 16 to 19, 20 to 23, and 24 to 27. Now the first frequency was 11. That is the same as before. So 10 and 15. Now it's not in the middle. 10 a little more than here, 11, right? And then the next is cumulative frequency 10, 20, 30, 36, 38, 40. So 10, 20, the second one in the middle. So this point should be in the middle here. This is 11 and then 20. So this one. And then in the middle of the third one is 30. So 30 is here. And then the fourth one, 36. 36 is here. And then 38. And then 40, the last one. So now you will join them with the straight lines like this, this, this. So it's kind of a polygon when we use cumulative frequency. Okay, so that is your ogive. So this is CF here, not F. So cumulative frequency on left. We can write here. Cumulative frequency. Okay. If we write cumulative frequency, it is ogive, and of course classes here. This is always classes, right? So here it was frequency. Here it was frequency for both polygon and histogram. Okay, so that is your lecture 1 and 2 assignment of lecture 1 and 2. B part is from lecture 2. Find mean, median, and mode. We know that mean, median, mode is we use formulas and we do that. Any other thing from the first two lectures? No, nothing. Find the length of the per minutes. Find the mean, median, mode. Yes, that's it. From second lecture. This was the only question, I think. And what is the skewness? Skewness is the symmetry, right? And here you see, it is not skewness is something when you have a tail. So there is something like at the beginning, something like that, but then you are having a tail, right? So it's kind of a positive skewed. Uh, we should have this type of picture, but it's okay. At the beginning, we have a little, two jumps there from 11 to 9 and then 10, and then we are having a tail on the right side, right? So this type of shape is there. So you can say that it is not a symmetrical distribution. We have a tail on the right. So right skewed or positive skewed, you can say that. Right or positive skewed. Both names are used when you have a tail on the right. Okay, so you can say that. Comment on the skewness means just look at the histogram or polygon. It will tell you some story about the distribution. So symmetrical is very unusual because symmetrical is something which is same. Even if there are two jumps there, but on the left and on the right side, we are having similar thing, right? They are same. Then we say it is symmetrical. No skewness. Symmetrical means no skewness. Symmetrical. Symmetrical means there is no skewness, non-skewed, no skewness. So, but we see that our distribution looks like this one, not this one. So we have some skewness tail on the right. So we can say that right skewed or right tailed distribution. Okay, so for mean median mode, I think we did examples. Even if I try to do B part here, so we should use grouped data because I have made frequency distribution, right? So if we have use this as grouped data, even though both data are given to me because raw data is given and because we have made uh, frequency distribution, so we should use group data. I think I wrote that here as well, using group data. So we know that for grouped data, I need the mean is, um, if you are calling it sample, is it a sample? Let's see. The following data represents the length of tire life in years of 40 tires. So of course this 40 tires has to be a sample, right? But they did not say anything whether it's a sample or not. So we can use anything. They did not say it is a sample. Um, we can use it as mean as a sample or population both. But usually when someone manufacture tires, he does not only manufacture 40 tires, right? There are hundred thousands of tires are manufactured. So we can take this as uh, a sample. Take as a sample. Okay. So if I consider, you can use it as population as well. There is no problem with that. So for group data, it is summation x fx by n, where n is sum of the frequency, which is 40, not 6. Don't take n 6. N is equal to 6 is wrong. N is not number of classes. Sometimes we count number of classes only. We say that, okay, we made classes. So these are 6 classes. So n is 6. No, n is not 6. N is this. This is your n, not the number of classes, number of observations, right? So we took 40 tires. So n has to be 40. So it means from the classes, I will make and the frequency is written. So I will make X the midpoints. They call these are called midpoints or class marks. They say class marks as well. But anyway, midpoint is common. So the first was 4 to 7. So we can take 4 to 7. So I see the next is 11 to 8 to 11, 12 to 15. So we can either take this midpoint of this 8 and 4 is 6. So I can start with 6. But if you add these two, if you add these two and divide by 2, it will become 5.5. So it can be taken as 5.5, no issues. And from 8 to 11, I can take 9.5, right? Then I can just add 4. Just pick one and then keep on adding 4. So it will become 13.5, 17.5, 21.5, 25.5, right? So 6 classes. But if you say, no, I want to to uh, round it to 6. If you round it to 6, that will also be fine. 6, 12, 16, 20, 24. 26, 22, 26. This will be 18, will be 14. So 6, 10, 14, 18. So either of these can be used. You can use this or you can use this as X. Okay, your choice. Using 6, 10, 14 is easy because you have to multiply next. You have to multiply frequency with X. And so it's better if you use this one. But if you use 5.5, nothing is wrong. All right. 10, 6, 2, 2. like that. So now we will multiply. So 11 6 are 66, 10 9s are 90, 140, 108, 44, and 52, right? So now you can add this one and get. So your x bar will become sum of fx over n, which is the sum here. You can make this complete this using so your total is here. This is sum of f, which is 40, and that is your n. And this is what you want, sum of fx, which is 66 plus 90 plus 140, 90 plus 140 plus 108 plus 44 plus 52. So this is 500. That's little strange. 500 by 40. So it gives you 12.5 is the mean. Okay. So that's how you can find the mean. I think it's correct, right? 11, 6, 66, 90, 140, 18 into 6, 108, 44, 52. I think this is correct. So hopefully you can double check my calculation. Okay. Do not just believe in my calculations. You can double check it. So this is your mean. For median, what we do, we calculate cumulative frequency, right? If you want to write the data, you can write it again. For median, you can write it again. Median is L M plus n plus 1 by 2 minus f plus 1 divided by fm into w, right? So first of all, I will find the median class. We know that the median is n plus 1 by second item or observation, right? So n is 40, so 40 plus 1 by 2 is 20.5. So 20 plus fifth observation. So that will come in cumulative frequency. So if I write classes frequency and I will calculate cumulative frequency. So 4 to 7, 8 to 11, 12 to 14, 15, 16, 20, 24, 7, 11, 9, 10, 6, 2, 2. Now cumulative frequency, we had 11, 20, 30, 36, 38, and 40. So see, this 20.5th observation is here, you see, because first class only takes 11 observation. Up to two classes, we have 20 observation. So 20.5th observation is somewhere here. So this is my median class, okay? Because 20.5th observation is here. Before that, it was 20. So this is my F. So this is my median class. Okay, so this implies that lower limit of the median class is 12, right? Frequency of the median class is 10. This is frequency. We don't need that because we need the previous one, this one. So this is my F, this is my FM, this is my LM, right? And class width is 4. We calculated that W was 4. So now if I replace everything, so therefore my median will be equal to LM, which is 12 plus n plus 1 by 2 is 20.5 minus f plus 1 is 21 because f is 20, right? So it is divided by frequency of the median class, which is, so it means 20th item becomes the median, not 21st. So divided by 10 into 4. So it will become 4 into 0.2. So 12 minus 0.2 is 11.8. So this comes out to be negative. So this is your median. For the mode, what you will do, L mode plus D1 over D1 plus D2 into it, where D1 is the difference of frequencies. So here, model class is the class with the highest frequency, which is the first one, right? First one is the model class. The mode is in the beginning. So if you want, I can write it again. You can work in one table as well, no issues. You can keep working on one table, but I'm just taking it as separate questions. So I'm making it again and again. 4 to 7, 8 to 11, 12 to 15, 16 to 19, 20 to 23, and 24 to 27. So frequency was 11, 9, 10, 6 to 2. So now highest frequency. So this is my model. The first class becomes the model class. Why? Highest frequency, right? Highest frequency gives me the model class. So this is called model class. Now this is your L. This is your frequency of the model class. So L is LM. Model class is 4. Then W is 4. Width D1 is the difference of this with the previous class, but previous class is not there. 11 minus 0 remains 11. And D2 is the difference of this with the next class, right? So that is 11 minus 9. That is 2. So now if I replace everything here, so therefore my mode will become L plus D1 is 11 divided by 11 plus 2 into width, which is 4. So 11 by 13 into 4. So 11 divided by 13 into 4 gives me 3.38 plus 4 gives me almost 7. 7.4. Okay. So now if you look at the mean, median, and mode, they are also telling me that there is a tail on the right. You see, because remember, if mean goes towards the tail, and then we have a median here, and then we have mode. Okay, so mode is on the left at 7 point something, median is at 11, and then this is 12. So it is an indication that we have a tail on the right. Okay, but we have actual picture, we have the actual picture, so we have already answer about symmetry. But usually the mode is the somewhere at the highest point. So this is your location of mode. Median tries to remain in the middle, and mean goes towards the tail. So see, so if the mean is the highest, if mean is the highest, it means we have the tail on the right. So this is the same thing we are getting from the calculations as well. The mean was 12.5, which is the highest among all these. So it means your symmetry, we have right-tailed distribution, or it is a positive skewness there. Okay, so I completed the first question. So you keep on working and try to complete other problems as well. Here in the second part, you have to find mean, median, mode, but using ungrouped data. So ungrouped is easy. There are 20 values, so you will just add them, right? So for the second question, what you will do in second question, you are using ungrouped data, so no frequency there. So it means this is easier. What you have to do, you need for mean, median, mode, and range, interquartile range. So you can do for mean, you want summation x by n. That's it. So n is 20 number of observation. You will just add all observations and divide by 20. It will give you the mean. So what you can do, you can write summation x separately. You don't have to show that you are adding everything. Just use your calculator, 2 plus 11 plus 8 plus 10 and so on. Get summation x. That's it. Then x bar will be summation x by n. That gives you the answer. For the median, you have to arrange the data. So 1, then 2, then 2, 1, 2, 2, 3. There is another 2. So you will first arrange the data 1, 2, 2, 2, 3, and keep on crossing out. I think 1, 2, 2, 3, and then there is no 3, and after 3 there is 5, 5, 6. So 5, 5, 6, and then 8, 8. 2 8s are there, and then 9, 9. That's it. 2 9s are there. 10, 10, 10. 3 10s are there. 10, 10, 10, and then 11, 13, 14, 15, 17. So 11, 13, 14, 15, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is the array of the data. Now there are 20 values, so 20 plus 1 by 2 is 10.5. So 10.5th observation is your median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10.5 is in the middle of 8 and 9. So your median will become 8 plus 9 by 2 because it is in the middle. So it is 8.5. All right. 2, 3, 5, 7, 10, 10, 20, 26. So anyway. And what is the mode? Mode is the most repeated value. So most repeated value is 10 and most repeated value is 2 as well. Okay, so there are two modes. So if you want to find the modes, modes are 2 and 10 because these are the two most repeated values. So this is a bimodal distribution. There are two modes there. Okay, so you can find that range is the highest minus lowest. 17 minus 1. Highest value is 17, lowest is 1. So that is easy. So I don't know what is that, but we calculated the median. The common mistake students do is they just write this as a median. 10.5. This is not the median. 10.5th observation is the median. So which is 8 plus 9 by 2. 10th observation was 8. 11th observation was 9. So median is this. Okay. Mode is the most repeated value. 2 and 10. Most repeated value. Right. So there are two values which are repeated 3 times. So you can find that. Then range. Lecture 4. Range is in lecture 4. So range is the highest value in the data set minus the smallest or lowest, highest, lowest. largest, smallest, whatever you can write. So highest was 17, lowest was 1, so 16 is the range. And then he said interquartile range. For interquartile range, I need two quartiles. Quartile is 1/4 fractile, right? So the third quartile minus the first quartile. Second quartile is the median, so that does not come in. So we divide the data into 4 equal parts. So this is Q1, the first quartile. This is Q3, the third quartile. So Q3 minus Q1. So that is my interquartile range. So first I will arrange 4 parts. So we have um, 4, 4. There are 20 values, so 5 values. So these 5 values give me the first portion. Next 5 values give me the 1, 2, 3, 4, 5 here. Okay, and these are the next 5 values. 1, 2, 3, 4, 5. So I think I wrote it wrong. This is the first 5 values. 1, 2, 3, 4, 5. Next 5. 1, 2, 3, 4, 5. These are next 5 and 1, 2, 3, 4, 5. So this is your Q1 and this is your Q3. And if you want, you can pick the last one from the first portion and the last one from the third portion. So 10 and 3. This can be interquartile range. Okay, so 10 and 3. So that is 7. But because it was in the middle of Q1 was in the middle of 3 and 5, so you may take 4 as well if you want. Okay, and this was in the middle of 10 and 11. So basically, here it was 3 and 5. Here it was 10 and 11. So they were in the middle. So if you want, you can pick the middle value here, which is 3 plus 5 by 2, which is 4. This will be more accurate. Okay, otherwise you can pick the third one, no issues. And here again it is in the middle, so Q3 will be 10 plus 11 by 2, which is 10.5. So these are actually very accurate. If you write 10.5 and minus 4, so this will give you 6.5. So this is very accurate, but 7 is also correct, no issues. Okay, so either you can pick this one, you can pick this as your Q1 and this as your Q3, and you can write 10 minus 3, which is 7. That is also okay. All right, so both are okay. So I hope this helps, right? I almost did 2 questions from here. So now you can complete other parts as well. In the third question, nothing is given. The length of the Powell failure is recorded. Find the sample mean and sample standard deviation of power failure. So there are many values, 45 values, right? But they did not ask us to make a frequency distribution like in the first question. There were 40 values, but they said make a frequency distribution. So here again, I can use ungrouped. It is a sample mean, so it means X bar, summation X by N. And sample variance, which is S square, right? So this is S, sample variance is S, which is summation X square by N minus 1 into N over N minus 1 X bar square. So this is the sample standard deviation, this one. So it means you need sum of X and sum of X square. So without writing squares of X in the calculator, you can just add all these values. It will give you sum of X just right here. And in the calculator, take the squares of each term. So basically in calculator, what you will write 22 square plus 18 square plus 135 square plus 15 square and so on. Keep on. And the last one is 93 square plus 95 square. So if you do that, just write this answer directly here. Okay, take the squares of each number and then add. So this sum of X will go here, right? And this sum of X square will go here. So do not make this mistakes. Sometimes students take the square of this, which will be wrong. Okay, do not take the square of this sum of x. Don't do that. This will be wrong. So sum of x square will come from here, taking the sum of every number. This is sum of x square. So that is also easy. So if I can write it here, in exercise 3. You can first find sum of x, which is 22, 18, 135. You don't have to write everything. Just in the calculator, just give these numbers. 93, 95, whatever answer you get, just write this answer. That's it. But then for x square, do not take the square of this answer. Take the square of each number. And again, you don't have to write all these things here. You can just give calculator these squares and write the answer only. That's it. OK, writing answers is enough, right? Answers only. OK, so but do write sum of x and sum of x squared. Then you can go to x bar, which is sum of x by n. Whatever sum of x you got, put it here. N was, I think, 45. So this will give you the mean. And then the standard deviation is s, which is sum of x squared by n minus 1 now. And n over n minus 1, x bar squared. This was the formula for sample standard deviation. So sum of x squared will come here. N minus 1 is 44, minus 45 over 44, and x bar, which you obtain here, put it here, square. OK, so whatever you calculated, put it here. So this will give you your standard deviation. So this is easy. Yeah. All right, so you complete this. Try to complete 4 and 5 as well. And then if you have any questions, we can discuss later. But hopefully now everything is fine here. Again, ungroup data 1, 2, 3, 4, 5, 6, 7, 8. Only 8 values. N is 8. OK, so sample mean and median, very easy. Then sample variance and standard deviation and range. From these statistics, comment on the quality of the data. You see, this is the a tire manufacturers want to determine the inner diameter of the certain tire. So he said ideally your tire diameter should be 570, but you see there are some deviations. So it means if you calculate x bar, it should be close to 570. This is a good thing. But then if you calculate standard deviation, it should be very small. If it is very small, it means the quality is good. OK, the tire are good quality, because if the spread is, it gives me the spread. So all the tires should be close to 570. But if they are far from 570, it means the tire quality is not good, right? So your mean should be small. That's what they are saying. Comment on the quality of the data. You can say that because the sample standard deviation is very small and the mean is close to 570, hence the quality of the tire is good. OK, if these two things happen, if your x bar is close to 570 and if your standard deviation is very small, then the quality of the tire is good. This is what you have to do. And I think same is here. There are two samples. Uh, Company A makes bulbs, company B makes bulbs. So he said find the variance standard deviation of the company A and company B. So for the variance, you need x bar as well. So you will calculate x bar and x separately. Number 4, calculate x bar should be close to 570 and calculate S. It should be very small. Then quality is good. If these are not true, then quality is not good. Then quality is good. I will share this file with you. That's why I'm writing this thing. So you have to calculate both things. OK, calculate these two things and then check whether these two are satisfied. Then the quality is good. In question number 5, calculate mean for company A, which is sum of x values from A divided by NA, right? N is same for both 8 values, and calculate x bar B, which is sum of x B values divided by N. Means you will add them separately. If you add these, it gives you sum of x A. If you add B, it gives you sum of x B. Okay, so you have to calculate x bar for A and B separately. And then standard deviation. Why I'm calculating this? Because I need these two for standard deviations. So SA will be sum of xa square by n minus 1 minus n over n minus 1 x bar a square. So that's why I calculated x bar, because I need it here. You see, that's why we calculated this. Similarly, I will calculate SB, sum of x b square divided by n minus 1 and n over n minus 1 x bar b square. So you calculate that. Now he said, comment on the quality of the tire, sorry, bulbs. Comment on the quality of bulbs and suggest which one is better. And here it said use measures of variation. So, measure of variation was called coefficient of variation. So coefficient of variation, we call it COV, right? So COV for company A, that is SA over X bar A, and you multiply by 100 and write it in percentages. And then you will calculate coefficient of variation for B, SB divided by X bar B, multiply by 100%. Whichever is smaller is better. Okay. Anyone which gives you smaller coefficient of variance is of better quality. Remember that. So you will calculate these two, whichever is smaller, you will say that the quality of that company bulbs are better. So if coefficient of variation of A is smaller than B, I will say that company A has better quality bulbs. Okay. So this is what you have to do. So again, question is about calculating mean and standard deviation. And after that, comparing coefficient of variation will tell you which has a best quality time. All right, guys, I think this will help. I have almost, uh, I did first fully, second also fully, but third, fourth, and fifth I left for you, but I gave you the hint, right? So hopefully now you can complete. Uh, no need to copy the assignments from anyone now, right? You can do it on your own. And also, if you do all the questions on your own, you will be prepared for these 4 lectures. Okay. Any questions, anything which you want to discuss? I can stop the recording and then take the attendance.